Hi guys! For your homework tonight, I'm going to have you go ahead and take your notes that you missed on Monday so that we won't get behind, considering I will be out next Monday because I will be in Austin for a UT conference. So if you'll go to your next spread, you're going to do 6 note boxes on the right, and then we'll make a tree map on the left, and I'll explain that kind of as we go along. Alright, we're reviewing kind of earthquakes, and if you remember, earthquakes are sudden causes by stress that happen in the earth. For some of you, this is how you are when UT gives you another assignment, stressed out. Basically what happens is stress builds up along a fault line. When it can't handle the stress anymore, it breaks and displaces or causes something to move along that fault line. So that leads you to box number 1. Again, today's notes should be pretty fast and easy. That's why I chose to do them as a homework assignment. What is an earthquake? You're going to title box number 1 earthquake. It's simply when the earth is shaking. It's the rapid release of energy due to tectonic plate stresses. And it occurs where the rock is brittle, not ductile. If you remember, ductile is like duct tape. Duct tape is going to fold. Brittle is going to be where it actually tears, like right here, it tore the road in LA. If you need more time, pause the video, but I'm going to go ahead and continue on. Again, an earthquake is simply stress. Again, some of you, this is the stress that you experience on a day-to-day. We're obviously talking about stress within the Earth's crust or lithosphere. So let's take a look at how this stress builds up over time. Alright, so this is a picture of a group of kids that are about to bounce a tire down a mountaintop. And as you can tell, as the mountain allows that tire to roll, the tire builds up.
Bouncy experiments became a bona fide internet smash that caught our experts' eyes.
And releases it in the form of kinetic. And then eventually,
I was watching in the first jump. It's like,
Wow!
Earthquakes are very much the same. In box number 2, you're going to title it Elastic Rebound Theory. Just like the tire built up with elastic potential energy, the elastic rebound theory simply states as the stress is applied along a fault, the rocks will bend, causing a gradual buildup of strain. We talked about stress and strain last semester. And then eventually, of course, it'll stick, and then it'll slip, stick, and then slip until eventually all that energy is released. Something like this. Have you ever used vice clamps before, maybe in your garage or at home? It's this idea that if you continue to add a bunch of stress to it, it's going to cause the rock to strain, the cracks are going to grow, and then eventually it's going to cause a fault line. Most of the elastic rebound that happens on the earth, just like with volcanoes, most dangerous ones are going to be found along subduction zones. And that's simply because as that plate grinds underneath because it's denser, it causes a lot of stress to build up until eventually it will release that stress in the form of an earthquake. And then of course you'll get uplift due to tectonic stresses that cause rocks to break. So this was kind of cute. Here's obviously the San Andreas Fault, the most common fault line in the world. New Madrid Fault, and then some people of course jokingly blame that as George Bush's fault. A fault is simply, of course, a break or a crack where the plate movement occurs. This is an aerial view of the San Andreas Fault. So we're going to write earthquakes occur when the strike-slip stress is larger than the strength of the fault. It can't handle it anymore, so it releases that in the form of kinetic energy. I can see here, obviously the fault line runs from side to side because the actual fence was moved along that actual fault line when that energy was released. Another kind of aerial view, this road used to continue all the way across, but obviously the fault line is right here, and when that stress built up, it released the energy and shifted the whole land to the side. Alright, so just because you don't have me for a class doesn't mean you don't get a joke. So here's your joke for the day. If you want, pause and see if you can figure out the punchline. What did the ground say to the earthquake? You crack me up. Alright, in terms of earthquake size, here is where this particular earthquake took place. and then it's going to radiate out in the form of what we called isotherm lines in terms of intensity. So in box number 4, you're going to title it Earthquake Size. Earthquake size is based on the amount of friction of the fault, the strength of the fault, and then the strength of the surrounding rocks. Again, if you need to pause to write down these notes, do so. We just said most of these occur along subduction zones, very, very similar to the ring of fire that we just talked about last week with the volcanoes. So box number 5, the deepest earthquakes are found along subduction zones. Now, when we try to figure out where an earthquake is located, we're looking at 2 different things. We're looking at the hypocenter, also called the focus. That's the spot within the earth where it's focused. And then the epicenter. That's right above where the land where the actual earthquake originated and then radiates out. Again, the focus is the point inside, the epicenter is on the outside. Different depictions of how that looks. So in box number 6, you're simply going to sketch and label that. Include a fault line, the hypocenter of focus showing that it's underneath the ground, and then the epicenter is directly above. One more just for your enjoyment. Ooh, there's some angry grapes there. What did the grape do when he got stepped on? He let out a little whine. Alright, this is going to go over on the left side of your notebook. On the left side, I want you to title it Types of Seismic Waves. You can take up the entire room if you would like. P waves, S waves, and surface waves. We've talked about these last semester when we were talking about the interior of the Earth, but we're going to review them real quick. Underneath each one, you're simply going to record facts about them. Alright, if you remember from basic physics, mechanical waves are mechanical, meaning they're moving away from an energy source. Think of ripples in a pond. Mechanical waves can include transverse or compressional. So a little bit of geophysics. Compressional waves are ones that move in the same direction. Okay? They literally hit each other as they move from, say, the speaker to the actual ear, as my voice is coming to your ear right now. Alright, so primary waves or P waves, you need to remind yourself on the left side of your notebook and take a note that says they compress and expand, similar to like if you coiled up a slinky and released the energy. They're the first wave to arrive at an earthquake. That's why they're called the primary wave. And if you remember from last semester, they can travel through both solids and liquids. Transverse waves, on the other hand, move perpendicular like a snake. They move up and down. Good examples of these would be ocean waves or an actual snake. They go side to side as they slither. These are good representations of S waves. They move the ground up and down or side to side. They're the second to arrive. And if you remember, they only go through solids. So S move like snakes and only go through solids. And they're second to arrive. Alright, so if I kind of look here at the P waves, again, they're going to compress and hit side to side. S waves are going to move up and down. And then the surface waves kind of do a rock and roll motion. They're going to go back and forth. So underneath your little chart that you made, surface waves, also called love waves or Rayleigh waves, move along the Earth's surface. They can move the upper crust in all different directions. And they're going to be the slowest of the 3. They're going to travel more slowly than S and P waves. However, they're the most destructive. So just when you think an earthquake is about to be over, along come these that carry the most energy, and because they're moving in all directions, they cause the most destruction. Alright, so I'm going to show you a video, and I want you to see if you can identify the 3 different waves, the P, the S, and the surface waves. Watch the lamp. Alright, I have the compressional wave about to start here. That's going to be the P wave. It's going to go back and forth. P wave, and then I have the S wave going up and down, and then I have the love or the Rayleigh wave going side to side with the most damage. San Andreas Fault, of course, is where most people usually think of actual earthquakes happening. That's simply usually going to be the southern portion of California. Remember, the northern portion is going to be a subduction zone. This is actually a transform zone here. It's the most active strike slip fault. Very, very dangerous. We'll talk next time how in San Francisco it destroyed almost the entire city of San Francisco in 1906, as well as most recently the World Series actually caved in the actual stadium where that happened. And that concludes your notes. So if you would, wrap up those notes and we'll talk about actual earthquake hazards next time and how to triangulate and figure out how they're formed so we can figure out where they came from and originated.